You know, you probably don't realize this, but right now, the absolute smartest AI systems on the planet are wasting massive amounts of time, compute, and, well, money, just talking to themselves out loud. Seriously, to solve the hardest problems in coding, math, and science, researchers link multiple specialized AI models together. But to collaborate, these models are forced to translate their incredibly complex internal mathematical thoughts into plain English text, hit send, and then have the next model read it and translate it back into math. It's wildly inefficient. But a brand new research paper has just changed the game entirely. Get this, 75.6%. Researchers have figured out a way to completely bypass that clunky text translation step, dropping AI token usage by a staggering 75.6%. And they did this all while speeding up the system's reasoning time by up to 2.4 times. They've essentially created a framework where AI models don't even have to talk anymore. They just share their thoughts directly. Okay, let's dive into this, because the core concept here is absolutely fascinating. What we're looking at in this explainer is a massive shift. We're moving from collaborative AI models acting like, slow pen pals to a system acting through a completely new kind of digital telepathy. Just imagine, if an AI agent could literally read the mind of another agent, how much faster and smarter could they solve complex problems?
To understand why this breakthrough is such a huge deal, we really have to look at the old way, what researchers call standard text-based multi-agent systems. Just picture a team of elite scientists trying to collaborate on a cure for a disease, but instead of brainstorming in a room together, they're locked in separate offices, and their only way to communicate is by writing incredibly long-winded formal text emails to one another. One scientist has to perfectly articulate their complex thoughts into English, hit send, wait, and then the next scientist has to read that entire email before they can even start thinking about their part. That is exactly how multi-agent AI works today. It is entirely bottlenecked by text.
And right there is exactly where that old method breaks down mathematically. It introduces two massive, massive flaws: latency and gradient vanishing. When you force an AI to decode its thoughts into a text vocabulary just to interact with another AI, you introduce severe latency. The agents are basically just sitting around waiting for text generation to finish. And even worse, when you try to train these models to work better together, that text translation step actually blocks the learning signal. It causes this thing called gradient vanishing. The models simply can't learn from their past mistakes effectively because that text barrier completely scrambles the feedback loop. Enter the hero of our explainer, Recursive MAS. The core thesis of this paper is, honestly, brilliant in its simplicity. They asked, what if we just rip out the text emails entirely? Recursive MAS steps in and replaces those clunky text-based interactions with direct, continuous brain-to-brain connections between the models. To understand how they actually pull this off, let's explain it like you're 5. Basically, before an AI spits out an English word on your screen, it first processes that information as a complex mathematical representation. Think of it as a raw thought. In the AI world, this is called the latent space. So instead of forcing the AI to translate that raw thought into English, Recursive MRs just grabs that continuous mathematical thought and hands it directly to the next AI in a continuous loop. No translation needed whatsoever. And this brilliantly illustrates the elegance of the whole system. It's like fitting puzzle pieces perfectly together. You see, Recursive LAS isn't just for models that are identical twins. It uses this lightweight, 2-layer residual projection module called a recursive link to seamlessly connect heterogeneous agents. In plain English, that means you can take a massive, generalized reasoning model and have it perfectly share its raw thoughts with a tiny, highly specialized coding model. They can have totally different architectures and different sizes, and this system connects their brains without missing a single beat. Okay, let's level up the technical explanation here to really see under the hood. The system trains these agents using an inner-outer loop paradigm. First up, the inner loop acts on a model level. It aligns an individual agent's latent thoughts, mapping its ongoing mathematical representations seamlessly back into its own input space. Then, the outer loop kicks in. This bridges those hidden representations across the different agents. It allows the system to share gradient-based credit assignments across the entire recursion round. Basically, the whole swarm of separate agents optimizes and learns as one unified brain. And because this recursive link is structurally agnostic, it's already incredibly compatible out of the box. The researchers successfully set this up across a highly diverse family of powerhouse models. We're talking major players here: Qwen 3 and 3.5, Llama 3, Gemma 3, and Mistral. So, the researchers successfully built this telepathic link. They connected the models, they cut out the text, and they got them sharing raw mathematical representations. Awesome. But there is a massive question here. Does all of this actually make the AI smarter? Well, we're going to look at the math in just a second.
Now, what's really interesting about the data they collected on the Math 500 benchmark is how things scale. When you track the recursion rounds, meaning how many times the agents looped their thoughts back and forth, the results are undeniable. As you scale up those recursion rounds, as the models spend more loops refining their latent thoughts together, the accuracy directly and consistently increases, peaking at a massive 78.4%. The deeper the recursion goes, the smarter the system gets.
And here's the kicker. They achieve that high level of accuracy while completely shattering the old speed limits. Because these models aren't wasting time generating thousands of intermediate text tokens just to communicate, Recursive MS achieves an end-to-end inference speedup of up to 2.4 times faster than the old baseline text-based multi-agent systems. You are literally getting a smarter answer in less than half the time. Let's see how this builds out across different setups. Take a distillation-style collaboration, for example. This is where they take a massive, slow, expert model, and they pair it with a smaller, much faster learner model. By linking them in the latent space with recursive mass, the system distills the expert's knowledge directly into the learner's workflow. The result? You get an average accuracy improvement of 8.3% across the board compared to baseline learner models, all while keeping a 1.5x speed advantage over just using the expert alone. It's the best of both worlds. So the crucial point for us is, how is this going to change daily life in the next 12 months? Well, consider a deliberation-style setup. This pairs an inner thinking reflector agent with a tool caller agent, which is basically an AI that actually goes out and writes Python code or searches the web for you. With recursive mass, these two agents can continuously deliberate in the background in a fraction of a second. The reflector can instantly critique a proposed web search or code snippet right there in the latent space before the tool caller ever even executes it. This is absolutely going to change the reliability of AI agents doing real heavy lifting work on your computer. To prove this whole thing wasn't just a fluke, the research team ran this framework through 9 rigorous benchmarks. And whether it's diagnosing complex conditions in medicine, solving advanced logic in science and mathematics, navigating live web searches, or generating Python scripts in code generation, Recursive Mass consistently delivers. It makes multi-agent systems fundamentally faster, significantly cheaper by slashing all that token waste, and measurably smarter. We are officially moving away from AI models slowly typing emails to each other, and we're entering an era of unified recursive latent space swarms. This massively drops the barrier to entry for running highly complex agent teams, whether that's locally or in the cloud. So I want to leave you with a thought to really chew on. If cost and speed were no longer bottlenecks, what massive, complex task would you assign to a blazing fast, recursive swarm of AI agents? Think about it, and let's keep the conversation going in the comments below.